Hello everyone, my name is Gaurav Baharkar and I am Data Science and Business Analytics Intern at Spark Foundation. So let's look at my task. My task is to find the optimum number of cluster and to present it visually from the iris dataset. So it's been a global issue to determine the optimum number of cluster because the selection of a cluster depend on the methodology we use and it might differ from dataset to dataset. Hence, I have tried using two approaches from determining the optimum number of clusters. The methodology follow in my code is first loading the dataset and the required libraries, then understanding our dataset, visualizing it, determining the optimal k value. So this is the major aim of our task, and I have applied using two methods. The first one is the Ilmo method and the second one is the silhouette analysis. The next method is using the optimal k value. We try to build the model and predict the output. So here goes the we are importing the data. So let's look at the code. So initially I have imported all the required libraries like NumPy, Pandas, Matplotlib, Seaborn, warnings, sklearn matrix, sklearn cluster k-means, sklearn matrix. Then after read CSV inbuilt function to read the dataset. Then df.head gives the first five values in our dataset, so we can see our dataset columns like ID, sepal length, centimeter, sepal width, petal length, petal width, and the target variable over here is to find out the species. So the species has Setosa virginica versicolor. Now let's look at the end also. Since we have tried to find out the first five columns, let's also look at the last five rows to see how many records are present using the data.tail inbuilt function. So we see it goes till 150, which means we have 150 observation. So the inference from this first step was that we found out there are 150 samples and 4 features, and we found out what our target variable is. So our target variable comes under the species column. Then we try to understand our data set. That this includes finding out from statistical measures to various descriptions about the shape of the data set and the data types and the data types. So our first step is to find out the df.info. So under this we found out the particular column has how many observations, what is the type of they are null or not null, and the data type of it. So we can see ID, which is just an identification column that is of type end, and the rest all are the type of float. Species has the type object. Then we use df.describe. This is a statistical function to give out the measures of a different attributes, such as how many count refers to how many observations are present, mean of those standard deviation, minimum 20 percentile of the data, 50 percentile. These are the quartile distribution representations. The maximum value which is present among these observation. Then we use the df.count species. The count species, that is how many are present. So we have Setosa, versicolor, and virginica. Each has 50 count. That means out of 150, it is an equally distributed data set. There is no imbalancing in the data set. Hence, we will not have to balance it. And each type has 15 offered. Then we try to find out if there are any null values or missing values in the data set. It is a very important step while we do data pre-processing. Hence, after doing this, it giving a summation of all missing values, we found out that none of the column has missing value. Hence, we need not deal with the missing values as well. Then we try to visualize our data. So here what I have done is I have drawn a box plot which is identified if there is any kind of outlier present in our data sets. So when I see over here all the points are covered within the box plot with the sepal sepal width has few points beyond its usual characteristics, but we can see that if we can see that it is not very far or very away from the usual data set. Petal length and petal width similarly have no outliers present. This at point can be at this point can be ignored as it wouldn't affect our drawn prediction. Then we try to find out if there is a correlation correlation between these variable, these features. I mean, so we try to use correlation using the Pearson method. It is one of the famous method to find out the correlation between the attributes. So dot correlation dot corr is the inbuilt method. So after running this, we found out that the diagonals of this matrix are 1 1 1, and then we see that few variables like sepal length and sepal width are negatively correlated, and since the coefficient is 0.87, which means that they are strongly correlated, such as kind of analysis play a huge role when we want to distinctly identify the cluster. But since that is not the aim of our analysis, we will just move forward knowing what all these attributes values are. Next, third step of the data visualization, I have drawn a pair plot between these, so we can see that the blue color represents the species category, the orange color, sorry, the blue color represents the Setosa category, orange color represents the versicolor, and the green color represents the virginica. So plotting the graph between them, we can see that for sepal length, this many value belongs to Setosa category, this many value belongs to versicolor, and this many belongs to the virginica. Similarly, when we try all different combinations, sepal length with our sepal width, sepal length with our sepal sepal length with our sepal width would give us this plot. So it's kind of a comparison of each attribute with the other attribute and the combination, and then we give a hue equal to the species to differentiate with the we giving the hue equal to species to differentiate with the with respect to species present in our data set. After looking at the trend in the species, we then try to find out the optimal k value. So here are the explain. We will be using the two different analytics method, elbow method and salute method. So first I would like to give a short description about what each method does. So in elbow method, what we do is we first try to plot a graphs between the values of the cost and the number of the cluster. That is, we try to find out if we increase the number of cluster, will increase the cost of clustering increases or decrease. So it is seen that as the number of clusters k increases, fewer elements are present in the k, because if you are increasing cluster, each cluster has smaller amount of points, so the average distortion between the cluster point decrease. That is somewhat similar to that. We can think of it in a way like if we are increasing the number of cluster, the points in it are decreasing, with mean cluster are formed when the points are very close to each other. This is an indication that the number of firm and dissimilarity amount of dissimilarity between the points is decreasing. So this particular point, when the dissimilarity starts decreasing, that is called the elbow point, which means that points belonging to cluster become more and more similar. So it uses a matrix WCSS, which is within cluster. It's quite some that is the distance between the points in a cluster square the distance square the distance, and then we try to find out the whether a point belongs to the right cluster or not. So if we look at the code over here, what we have done is, first term, create a new data frame, dropping the target variable, and then we use this list WCSS, which is a list which will contain the distance between the square distance between the clusters of point. Then we run a for loop to find out the distance and keep appending it in our list. After doing that, when we try to plot a graph between the number of clusters and those within clusters, we find that elbow occurs at 2 and 3. and also slightly at the 4. The graph may vary from different people, different types of analysis, but the considering if we have 2, 3, and 4 are our elbow points, we need a way to decide if the number of clusters are going to be 2, 3, or 4. So we go ahead with a silhouette analysis. So silhouette analysis is usually used to measure the quality of a cluster. It not only depends on the how distance a point is from a centroid of a cluster, it also measures the quality. So how this is done by using the average fill out coefficient. So this particular coefficient is calculated for different k values, whichever has the maximum sellout score that is selected as a cluster. So over here we can see that, see, when we run our analysis on our number of clusters, we find that for 3, the sellout score is 0.58. Before it is 0.55. It is a 0.55, although the variation is not huge. But when we compare this to our previous analysis, we can see that 3 is the very good candidate to classify as the optimal number of clusters in this particular data set. So the inference from this analysis is that if the number of clusters is 3, we can find an optimal clustering of our data set. The next step is to building the model. So now we will use the optimal number of clusters, which is 3, to build our model. So we initialize it with 3 and keep increasing, if increasing, to predict the model. After prediction is done, after this model is built, we try to visualize how the data set is classified. So here goes the code for building the scatter plot. After building the scatter plot, we can see that we have the classified this value to be class Setosa, class Virginica, and class versicolor, and the red dots are the centroid of each class, each cluster. So we can make out a little from this 2D plot. We also try to build a 3D plot for better visualization. So this looks this way. So it is sometimes easier to classify our cluster data points. When we increase the dimension of our analysis in 3D, it becomes much more simpler to classify, I mean to cluster the data points. Next we try to build the blocks box plot, which we did was only between the attributes. Now we try to do it with between the attributes and the classes. So we can see that Setosa are usually, if the sample length is less, it belongs to the Setosa class. If the sample length is moderate, it might belongs to the versicolor, and if the petal length is high, it might belongs to the virginica. Similarly, when we do the comparison with this sepal width, if it is moderate sepal width, it might belong to the Setosa. Lower sepal width belongs to the versicolor. A bit higher than the might belong to the virginica. Similarly, for the petal length and the petal width, this box plot clearly defines the characteristic which is particular lower should have to belong to cluster. So the inference from this analysis is just to find out the characteristic of the point belong to a cluster. So the conclusion of this is I had successfully find out the optimal number of cluster, which was the aim of this analysis, and it is found to be 3, and I was also able to build the unsupervised model out of it using k-means clustering. Hence an analysis is complete. Thanks for watching.